Okay, this is going to be problem number 1 from the 2026 Calc A, B, and BC exams. It's a table problem and kind of an additional stuff problem. Let's take a look at it. So problem number 1, or part A, I should say, says male birds of a certain species arrive at a nesting area over a 30-day period. The rate at which the male birds arrive at the nesting area at time t days is modeled by a differentiable function m, where m of t is measured in number of birds per day. I was going to say number of birds of prey. Selected values of m of t are shown in the table. Approximate m prime of 7.5 using the average rate of change of m over the interval from 5 to 10. Show the work that leads to your answer. Indicate units of measure. Okay, so this one is pretty straightforward. We're going to find or approximate m prime of 7.5. So approximately, so an approximately equal to sign. And then they told us what to do. So we're just going to do m of 10 minus m of 5 over 10 minus 5. This seems to be a thing they're doing on the modern exam where they tell you exactly what interval to use. Didn't used to be that way, but it seems to be now. Now we just pull the values from the table. So at 10, it's 16. At 5, it's 7. And then 10 minus 5 is 5. So we get 9 over 5. We need to include our units of measure. So that's going to be the units of m, which is birds per day, and then per days. So we're going to write birds per day, and we're going to leave it like that. Let's take a look at the next part. Use a midpoint Riemann sum with 3 subintervals, 0 to 10, 10 to 20, and 10 to 30 to approximate the integral from 0 to 30 of m of t dt. Show the work that leads to your answer. Okay, so we'll start off, we'll write our integral, and it's approximately equal to. Now we're going to go to the table. They told us the intervals to use. It's got to be from 0 to 10. So if you go from 0 to 10, the midpoint is 5, so the height you'll use is 7. And then from 10 to 20, the midpoint is 15, so the height you're going to use is 6. And then from 20 to 30, the midpoint is 25, so the height that you use is 2. We can write this down. So what we're doing notationally is we're doing 10 times m of 5 plus 10 times m of 15 plus 10 times m of 25. But we do not leave it that way. What we're going to do is we're going to fill in the values. So this becomes 10 times 7 plus 10 times 6 plus 10 times 2. And so that's 150. I think you actually could have left it as 10 times 7 plus 10 times 6 plus 10 times 2, but it's easy enough in this case. So I just went ahead and did it. But you definitely could have left that without simplifying it. Interpret the meaning of the integral from 0 to 30 of m of t dt in the context of the problem. Okay, so I'd like to start off by writing down the integral. So the integral from 0 to 30 of m of t dt. If you're integrating a rate, you get a total. So this is the total. What is it the total of? Well, m of t is birds per day, so it's going to be birds. But I like to go back to the entire context, right? So this is male birds arriving. So I'm going to say it is the total number of male birds that arrive. And then we need to say what these bounds are, right? 0 to 30. So I'm going to say on the time interval from t equals 0 to t equals 30 days. So in the context of the problem, it means like what are the units basically? What does our integral represent? What are the units on that? So I think that this is a good answer. Let's take a look at the next part, which is going to be about female birds. So the rate at which female birds of the same species arrive at the same nesting area in birds per day is modeled by the function f defined as follows. They don't show up at all between 0 and 15, so the rate of change is 0. Then they show up sinusoidally between 15 and 45. This is a calculator problem, so it doesn't really matter what that function is. We're just going to define it on our calculator. How many female birds of this species arrive at the nesting area from 15 to 45? Show the setup for your calculations, round your answer to the nearest integer. Calculator problem, all we have to do is the integral from 15 to 45. Integrate the rate, you get the total. So 15 to 45 f of t dt. I punched it in on my calculator. I got approximately 641.859, but then the question says round your answer to the nearest integer. So I said approximately 642 female birds arrive. I don't think you need to write a sentence for this. I think you just needed to say that integral is approximately 642. I believe you would get all the points for that. Let's look at the last part of this question. On the interval from 15 to 30, the difference in the rates at which male and female birds of this species arrive at the nesting area can be modeled by the differentiable function d of t, which equals m of t minus f of t. I actually didn't read the problem. I didn't see that it said d of t was differentiable. Where f is the function defined in part C, is there a time in the interval 15 to 20 when d of t equals 0? Justify your answer. Okay, so I accidentally have justified that d of t is differentiable. I said m of t and f of t are both differentiable, therefore d of t is differentiable. They already gave that to us, so you could have just started with d of t is differentiable. What you definitely need to be true though, we're going to use the intermediate value theorem, so you need d of t to be continuous. Differentiable implies continuous, so as soon as we write d of t as differentiable, we can say d of t is continuous. Once we have that, we're allowed to use IVT. We just need to figure out what's happening on the function d at 15 and 20. So this is a calculator again. So d of 15 is m of 15 minus f of 15, which I got 4, which is greater than 0, obviously. I then calculated d of 20, so d of 20 is m of 20. You're getting the m values from the table and the f values from the function. So m of 20 minus f of 20 is negative 1.686. That's less than 0. So now we're set up for the intermediate value theorem, so we can just use it. Since d of t is less than 0, is less than d of 15, d of t equals 0 for some t between 15 and 20 by the intermediate value theorem. That's all of question 1. I hope this was helpful, and good luck.